Okay, we're going to look at some linear recurrence relations questions. Recurrence relations being of the form un plus 1 equals aun plus b. Okay, so example 1. A patient is injected with 156 millilitres of a drug. Every 8 hours, 22% of the drug passes out the bloodstream. To compensate, a further 25 ml dose is given. Every 8 hours. Okay, so part A says find the recurrence relation for the amount of drug in the bloodstream. So that would be un plus 1 equals, well, 22% passes out the bloodstream, which means 78% remains. And then the constant value that's added in every 8 hours is plus 8. Or rather, plus 25 every 8 hours. So un plus 1 equals 0.78 un plus 25. Okay, the question then says calculate the amount of drug remaining after 4 hours. Well, this recurrence relation is set up to repeat every 8 hours. So we can say that u0 is the initial value. The initial value, remember, was 156 millilitres. So then u1 would occur 8 hours later, so that would be 0.78 lots of u0, which is 156 plus 25. So after 8 hours, that would be u1, and that would be equal to 146.68 millilitres. I'll then investigate what's happening after another 8 hours, so that would be 16 hours. So that's then 0.78 lots of u1, which is 146.68 plus 25. That will then give me 139.4104. By repeating that process in the calculator then twice, the calculator then recognises it's a recurrence relation, and the equal sign can be pressed beyond that, which will then set up the recurrence relation, and u3 after 24 hours will be 133.74 millilitres. Okay, question 2. A sequence is defined by the recurrence relation un plus 1 equals 0.6 un plus 4, u0 is equal to 7. Calculate the value of u3 and the smallest value of n for which un is greater than 9.7. Okay, so u1 would be equal to 0.6 lots of u0, which is 7 plus 4. So that will then give me 8.2. I then repeat the process, so u2 will be equal to 0.6 lots of u1, which is 8.2 plus 4, which that will then give me 8.92. By then pressing equals in the calculator after having entered the pattern of the recurrence relation twice, the calculator will then recognise it's a recurrence relation and give you the following result. So u3 then will be 9.352, and that can be gotten by pressing equals in the calculator after having entered the recurrence relation twice. Second part of the question was to find the value of n for which un was the smallest value for n for which un is greater than 9.7. So hit equals on the calculator again for u4, and that will give me 9.6112, and then 5, which will give me 9.76672. So the smallest value of n for which un is greater than 9.7 is 5. Okay, we're now going to look at the limit of a sequence, and remember that a limit exists when a is between -1 and 1, when we have a recurrent solution of the form un plus 1 equals aun plus b. And remember that the limit is given by L equals b over 1 minus a. Okay, so example one of these. The deer population in a forest is estimated to drop by 7.3% each year. Each year, 20 deer are introduced to the forest. The initial deer population, which we could call U0, is 200. Okay, so part A, how many deer will there be in the forest after 3 years? Well, we can set up the current solution here. Un plus 1 is equal to, well, it's a drop by 7.3%. So that would suggest that we've got 92.7% left. So 0.927 UN, but to compensate, 20 deer are introduced, so that would imply that we add on 20. And remember that U0 is equal to 200. So we're interested in what's happened after 3 years, so that would be U3. So U1 is equal to 0.927 lots of 200 plus 20, and that will give me 205.4. Repeat the process for year 2, 0.927 lots of this time U1, which is 205.4 plus 20. So that then will give me 210.4058. U3 then can be gotten by pressing equals in the calculator, since I've already entered the pattern for the current relation twice, and that will be 215.0461. So we could say then that 215 deer live in the forest after 3 years. Okay, part B of the question is, what is the long-term effect on the population? Well, that's implying that we should look at the limit. Well, first of all, a limit would exist since 0.927 lies between -1 and 1, and to get the limit it would be b over 1 minus a. So then that's 20 over 1 minus 0.927. So I then enter that into the calculator, and that will give me 273.97 to 2 decimal places. So therefore, the number of deer will settle around 273. Okay, the next one we're going to look at is a sequence as defined by the recurrence relation un plus 1 equals kun plus 2k, and the first term is nu naught. Given that the limit is equal to 27, find the value of k. So L equals b over 1 minus a, where L equals 27. So there's b, 2k over 1 minus k is equal to 27. I can then cross multiply, right, 27 is 27 over 1. And that would give me 27 lots of 1 minus k is equal to 2k. So that's 27 minus 2k, or rather 27 minus 27k is equal to 2k. I can then bring that across, change the sign, and that will be 27 is equal to 29k, which implies then that k is equal to 27 over 29. Okay, next question. A sequence is defined by un plus 1 equals aun plus b, with u1 equals 4, u2 equals 3.6, and u3 equals 2.04. Find a and b. So this is a simultaneous equations type question. So if we take u2 to be un plus 1, so that would be 3.6, then the previous term un would be then 4, so that would be 4a plus b. That's equation 1. If we were to take un plus 1 as u3, then that would be 2.04, and the previous term would be u2, which is 3.6, so that would be 3.6a plus b. Call that equation 2. I can then do equation 2, take away equation 1, and that will get rid of the b's. So that will be minus 1.56 is equal to minus 0.4a, and the b's will cancel out. A is then equal to minus 1.56 divided by minus 0.4, which is equal to 3.9. I can then sub a equals 3.9 into one of the equations, and I'm going to sub it into equation 1, which is 3.6 equals 4a plus b. So then b is equal to 3.6 minus 4a. So that's 3.6 minus 4 lots of 3.9, and that's equal to minus 12.